So the objective to this video is to be able to evaluate and simplify natural logarithmic expressions and to be able to solve equations using natural logarithms. So before we get to all of that, I would like to talk about what a natural logarithmic function looks like. Okay, so there's a couple things that we need to know. Is that one, the logarithmic function, the natural logarithmic function, is an inverse of our exponential y equals e to the x. It's also written as y equals the log of x base e. So notice that base is e. But more often than not, we write it as y equals ln x. And ln just means natural log of x. So we would read that as y equals natural log of x. Okay? And we're going to end up using those same properties we learned for logarithms and apply them to our natural logarithms. All right, so a natural logarithm, I'll just pick purple here, has a base of e. And keep in mind that e is equal to approximately 2.718. Okay, so it has a base of e. So let's go ahead and show you what this looks like graphically. So if I'm going to graph y equals e to the x, that is the exponential, all right? I'm going to plug in -2. Well, e to the -2 power, well, that would be 2.718 raised to the -2 is equal to about 0.1353, okay? If I plug in -1, e to the -1, well, that would be 1 over e, and that is equal to about 0.3679. E to the 0, well, anything to the 0 is 1. E to the first, well, 2.718. And then e squared is 7.389. Okay, so let's go ahead and graph this. I have the point -2 and 0.1353. And then I have the point -1, 0.3679, 0, 1, 1, 2.718, and then 2, 7.389. Okay, so this is an increasing function, looking a little like that. Actually, you know what? Let me kind of fix that a little bit. So it's going to level off there. That looks a tiny bit better. Okay, so that is y equals e to the x. I also want to point out it does have that horizontal asymptote at y equals 0. Okay? So let me get orange here, and let's graph the inverse of it. So the inverse of y equals e to the x is the natural log of x. So probably shouldn't have put the x values in, because what happens when we have those x values? You switch your x and your y values, right? So that means I would have 0.1353 -2, and then I would have 0.3679 -1, 1, 0, 2.718, and then 7.389, 2. So let's graph that. So 0.1353 -2. I have 0.3679 -1. I have the 0.10. I have the 2.718, and then 7.3892. Okay, so let me do my best to try and graph that. Okay, so with this, it's going to have a vertical asymptote at x equals 0. Okay, so for our natural log of x, it has a vertical asymptote at x equals 0. Now, points that will be important for us to graph, especially for when we do transformations, I would be focused on that vertical asymptote, and I would focus on 1, 0, E1. And know that E is 2.718. So if I would go ahead and draw this symmetry line, and that is that y equals x, that gives me the reflection over that line, gives me the inverse, okay? You can see that if I fold it on that line, the two graphs will lay right on top of each other, okay? It has symmetry with respect to it. So that is our natural log of x. Again, that's going to be another parent function. Well, I told you right at the beginning that we were going to evaluate and simplify natural log expressions. So let's go ahead and do that. First thing I want you to do is apply those properties that you learned with the logarithms. And we're going to apply them to our natural logarithms. Okay, so here I see this 2. It is the power property, so it's going to be written as natural log of 5 squared. And 5 squared is 25. And then when we add our logarithms, that is the product property. That means we're going to multiply the 7 and the 25 together. All right, so that would be the natural log of 175. That is written as a single logarithm. Okay. Looking at number 2, we have 3 natural log x minus 2 natural log of 2x. I see the power properties here. I see 2 of them. So that would be written as natural log of x to the third minus the natural log of the quantity 2x squared. Well, that is the natural log of x to the third minus the natural log of 4x squared. When we subtract logarithms, that means we're going to divide, and it's always going to be the first one, x to the third, divided by the second one, which is 4x squared. So now, x to the third divided by 4x squared, you got to simplify that. That's going to be x over 4. And that is written as a single logarithm. Okay. Looking at number 3, we have 3 natural log of x plus 2 natural log of y plus natural log of 5. All right, first thing I'm going to deal with is this multiple, the power property here. So I have the natural log of x to the third plus the natural log of y squared, and then I have this plus natural log of 5. All right, well, here's what I know. We are adding all of these. That is the same as the product property. We're going to multiply that x to the third times y squared times 5. So that is the natural log of 5 x to the third y squared. And that is written as a single logarithm. Okay? So you can use that relationship between the functions y equals natural log of x and y equals e to the x to solve certain logarithmic and exponential equations. So now we're going to solve equations using natural logarithms. Okay? So taking a look at number 1, I have natural log of x equals 2. This is in log form. So the natural log of x is the same as the log of x base e, and that equals 2. Now I can change this to exponential form. That would be e to the second power equals x. Well, e squared is 7.389. And that's how you find x. Looking at number 2, I have the natural log of the quantity 3x plus 5 quantity squared equals 4. Well, if I want to change this to the natural log is a log of a base e. So let me write that out. Change this to exponential form. That would be what? E to the fourth equals the quantity 3x plus 5 quantity squared. All right, well, let's see here. E to the fourth. Well, I'm going to leave it e to the fourth for now. Equals, well, I need to FOIL this right-hand side. I have 9x squared plus 15x plus 15x, that's a 30x plus 25. Okay? So when I take 25 minus e to the fourth, I'm going to have 0 equals 9x squared plus 30x minus 29.5981-ish. Okay? Well, I have a quadratic. How do you solve a quadratic? Well, since I got some decimals in there, it looks like quadratic formula is going to be it. So A is 9, B is 30, and C is this negative 29.5981. I have x equals negative b, 30, plus or minus square root of, that's 30 squared, minus 4 times a times c, all over 2 times a. So I get negative 30 plus or minus. Now, what do I get underneath the radical? When you evaluate all of that, you get 1,965.5316. And that's going to be all over 18. All right, well, here's what I know. The square root of that number is right around 44.3343, all over 18. So when I take the negative 30 plus the 44.3343 and then divide by 18, I'm going to get 0.7964. And when I take negative 30 minus that 44.3343 divided by 18, I get a negative 4.1297. And there are our two solutions that when I plug them back in, they work. All right, so always when you have natural logarithms, you need to check your solutions. Okay, plug it in, see if it works. Let's do another example. For number 3, natural log 2x plus natural log of 3 equals 2. Well, the first thing I have to do before I put it into exponential form is to write it as a single logarithm. Well, let's see. Write this as a single logarithm. I'm adding them. Well, that means if I'm adding them, I need to multiply. Well, that's the same as natural log of 6x. Now, a natural log is the same as the log of 6x base e. Now I can go ahead and change it to exponential form. E squared equals 6x. I'm going to divide by 6. And when you take e squared divided by 6, you're going to get 1.2315. Okay? And that would be your solution. Now look at number 4. Number 4, well, it is in exponential form. So what we've learned so far is that we need to take the log of both sides. But since the base is e, I'm going to take the natural log of both sides. Natural log of both sides. Okay. Now you can use your log properties. If I have a power of x minus 2, that's going to go out in front. So it's the quantity x minus 2 times the natural log of e equals the natural log of 12. All right, well, let's see. Natural log of e, well, the natural log of e is 1. Okay? So if the natural log of e is 1, I get x minus 2 equals natural log of 12. I'm going to add 2 to both sides. X equals 2 plus the natural log of 12. This is an exact answer. Okay, an approximate answer would be to actually figure out what the natural log of 12 is, then add 2. So that is equal to 4.4849 if you figured that out. This is an approximate answer. Okay? I'm good with either one of them. A lot of times I'll just use the exact answers. Okay? All right, last two examples. We have 2e to the negative x equals 20. Well, I need to isolate that e to the negative x, so I'm going to divide by 2 on both sides. E to the negative x equals 10. All right, so here's what I know. I'm in exponential form. Since the variable's in the exponent, to get it out of the exponent, I've got to log both sides. Since the base is e, I'm taking the natural log of both sides. The exponent becomes that multiple. That's your power property there. So I have negative x times the natural log of e equals the natural log of 10. We've learned that the natural log of e is 1. So I have negative x equals natural log of 10. Now I'm going to divide or multiply, if you will, by a negative. That's a negative natural log of 10. That's an exact answer. Decimal answer would be negative 2.3026. Okay. In our last problem, I have e to the 3x plus 5 equals 15. Well, first of all, you got to subtract 5. I got to isolate that base to the exponent. I have e to the 3x equals 10. Since the x is in the exponent, to get it out, I have to take the log of both sides. Since the base is e, I'm going to take the natural log of both sides. Once I do that, I see this power becomes that multiple. That's 3x times the natural log of e equals natural log 10. We know the natural log of e is 1, and that gives me 3x equals natural log of 10. So now I'm going to divide by 3. So that is the natural log of 10 divided by 3. That is an exact answer. If you take the natural log of 10, make sure you hit enter or close that parenthesis before you hit divided by 3. That decimal answer would be 0.7675. Okay. Hope that helps a little bit for you with evaluating, simplifying, and then solving equations with natural logarithms.